10 is titled The Mole in all its fascination. The mole is a quantity of matter. It is considered one of the basic measurements of the SI. It's an SI unit, meaning it's basic. So what happened there a long time ago, not that long ago, in the early 1700s, 1800s, there's a gentleman by the name of Avogadro. He was studying gases, and he said, okay, we have to talk about numbers of atoms. We're going to talk about how many things I have that I'm working with. Numbers. Okay, and the reason for this is now we've all worked on it, the law of conservation of mass energy. The law of conservation of mass energy, meaning we have to, what we start with is what we have to finish. Everybody's saying, well, what good is that? Yes?
Wait, do
what?
we have to though? Oh,
Well, some of it you will.
Okay, just tell me when I have to.
Okay, I'm going to tell Jaden Shepard, because I'm taping this for posterity, to tell him that he has to write this down as needed. If I was working for a company and I wanted to find out how much I needed, how much stuff I needed to make one thing into another, I need to know numbers so I can take, if I'm going to start with 5 grams of something and I add it to 7 grams, I should get pretty close to 12 grams when I'm done, right? And if I don't, that means that my particular experiment was wasteful and I could cost my company a lot of money. So it comes down to that, we want to know how much. How much are we really working with? So the gentleman devised a number was using gases, and he came up with this idea that 1 mole of substance is equal to 6.02 times 10 to the 23rd units. Now these units could be various things. It could be atoms. If it was covalently bonded, it could be molecules. And if it was ionically bonded, it would be formula units. And I'll get out of your way here so you can write this down. Excuse me. I have baggies of stuff.
Hiatus lose baggies of stuff.
Like right there.
Yeah, perfect. Thanks, Doc. Okay, my baggies of stuff. My baggies of stuff say this. All right, I would like you to know that this is 1 mole or 6.02 formula units of sodium chloride or table salt. This is 1 mole or 6.02 times 10 to the 23rd molecules of sucrose. I would like you to know that this is 1 mole or 6.02 times 10 to the 23rd atoms of carbon. I'm waiting for a question. I'm letting you know that this baggie of copper is 6.02 times 10 to the 23rd atoms of copper. Question?
Mine's about money. So copper is worth money, you know. So
Yeah.
how much would you have to make a profit?
Anything. I mean, how about 3 moles? Okay, that's a good question, because if you were talking about actual particles and you could tell that they're different sizes.
Well, like my dad's friends, they got in trouble one time, like when they were kids, because they were stealing copper out of somebody's backyard.
Mm-hmm.
So I mean,
It is. It does make a difference.
It's worth something.
It's worth something. This is masked out to be a certain amount. And we'll get to the reason why the masses are different. But where's the question? Here is salt, here is sugar.
Why did you call that sodium chloride?
Because it's sodium chloride, it's salt.
Why are they different?
I didn't know that.
Thank you, Nate. You asked the correct question. Why are they different amounts? All right, because a mole is based upon what it is. If I have a formula unit of sodium chloride, remember this is a formula for sodium chloride, right? If I have sucrose, is that C12H22O4? How large is this molecule compared to this formula unit?
A lot bigger.
it's a lot bigger. Therefore, these are larger molecules, it's going to take up more space, it actually is gonna have more mass. So not only is the moles, how many, it's also gonna be based upon is what the mass is.
It's based on that or doesn't involve that?
It does involve that. It's also based on that. It's really weird. It's really complex. It's really amazing that they found this out. Okay, yes.
Did they just pick a random number or is there a reason?
No, there is a reason for that number. And I think we're gonna go baby steps on this, only because if you understand this part right here, and then we're gonna talk about some mathematical processes. So this is where you're going to need to have your calculators available. So if I'm giving you, you know that 1 mole is 6.023 times 10 to the 23rd units of anything. 3.5 moles. Okay, we're just going to use magnesium because it's very simple to write. If I have 3.5 moles of magnesium, how many atoms are there? So we're going to be using the idea of dimensional analysis. So we're going to we've done this before, the dimensional analysis, plus we're going to use our calculators a little bit. So let's get ready for that. You have 3.5 moles. Now, I'm going to show you what I do because in science we want to minimize the symbols. So if I had 3.5 moles of magnesium, and I would say, okay, and there are 6.02 times 10 to the 23rd atoms in 1 mole of magnesium. This is how maybe you would write it, maybe you wouldn't have the 1 here, but it's the dimensional analysis. We're going to do a little bit different. We're going to say 3.5 moles magnesium. We're going to set up a grid system.
Why does the 1 go under it? Just because why not?
Why not? A grid system like this, can you see that, Saul?
Yeah.
Okay, that grid system is a little bit handier because here I have 2 multiplication symbols, and if I'm a messy writer, I can see where I might get a little confused what I mean by this and how things are going, like what am I really multiplying here? And what labels am I really using? So when I use dimensional analysis, if I have moles of magnesium up here, I have moles of magnesium down here. Just look at the labels. I know that I could take any number times 1, and what am I going to get?
Same number.
Same number, or equivalent numbers. If I have 1 dozen eggs, how many eggs do I have?
1 dozen or 12.
I have 1 dozen or 12, right? Both mean the same thing in our mind, correct? The same thing here. 1 mole is the same as 6.02 times 10 to the 23rd atoms. So if I have, this is my 1, this is my original number, 3.5 moles of magnesium, and my factor conversion, and I can figure it out. Because when I look at this, I'm left, these can cancel out, these symbols or the labels can cancel out, and I'm left with atoms. So how do I do this on my calculator or on my phone or whatever? So given a calculator,
You could do 3.5 times 6.02. Just do that, then when you're done with that, add 23 zeros, I guess. Or not.
no. Okay, I have a scientific calculator here. Maybe, is that better right there? Can you see a little bit more? I turn it on. That's always helpful, clear. All right, parentheses are a beautiful thing. Can you all say that with me? Parentheses are a beautiful thing. It's gonna help us. So on the bottom, right here, I'm gonna take 3.5 times, this little line right here means times, 6.02 times 10 to the 23rd. So to do that, 3.5 times parentheses, and I don't know why it works so much better with parentheses, but it does.
Wait, Miss Wells, do we have parentheses in our phones?
Yes, you do. 6.02, with me? I'll show you on the calculator first, and I'll go get my phone. To help you out here. Okay, you'll notice that there's this little EE button right here. Okay, the EE button is in place of the times 10. So I go this, the EE button,
What'd you
23. Second EE.
Okay.
Thank you. Okay, I put the other parenthesis in, I press enter, and I should, now if you look at this, I don't know if you can see it, it says 2.107 times, there's a little times 10 to the 24th. Do you get that?
I missed the part how you put the power in there.
Yeah, where'd you put 20?
Okay, 3.5, parenthesis, got that part?
Okay, wait. 1 second. 3.5 per. Wait, do I have to put times?
Yeah.
Parentheses, 6.02, that part is good. Okay, I want this little EE yellow.
When I put parentheses on my phone, like the parentheses don't show
She's
up.
gonna show us how to do it on the phone back.
Okay, there,
Alright, then I'm just gonna wait.
see that?
Yeah.
Okay, and then I go 23, that little E right there
Means
represents times 10.
Okay.
Parenthesis equals, and I can write that down real quick to make sure I get the right answer again. It tells me that it's 2.107 times 10 to the 24th. And we're gonna talk about that answer in a little bit. Okay, on my phone, kinda different, because considering the amount of money that they spend, I'm sorry, and this is being videotaped and everything else, but, considering the amount of money that they have, two numbers out, I got 2.107 times 10 to the 24th. My answer is going to be 2.1 times 10 to the 24th. Yes or no?
Yes.
Because I have to use significant digits.
Only two.
What?
You need only two in your answer?
Because my original problem only has 2. Okay?
And how do we know if they're not significant?
Do you round
I
up?
still don't understand how you do this.
Well, what do you mean? Ask me again.
Because there was like 15 rules that you had
There
to
was
remember.
5 rules.
There was about 5 rules. And
Yeah.
I still don't get it.
You have to look at, zeros really don't count unless they're between numbers. That's just all you have to remember. I mean, that's the basic rule. So if you have, the question is, if I have 7.03, that's 3 significant.
Okay.
Right?
What if
I
there's a
have-
zero?
You know,
If I
I'm
have
hoping you say no, that's stupid, but-
0.73, that's insignificant. That's 2.
It's like 700.
That's 3.
It's
One.
Yeah, I know, I don't understand.
How many is that?
Okay, wait. 3.
But
See-
see, it's just zeros going on forever after that. What makes those significant?
Because that means I counted to
Wait, I have a
700.
question, Ms. Wells.
What?
What if it's 0.0073?
0.0073. 2.
Okay, what if it's 0.7300?
0.7300.
Oh my god.
What?
Jade,
Because they're showing showing.
I'm showing that I measured this up to here. You're showing how far I measured. These are placement values. This shows me I measured up to this value. It's called for precision and accuracy.
Okay, wait, so what if it's 700.00?
Then all those count.
All of them?
Anything up to decimal counts. But
So-
don't worry about it. Here's a rule of thumb. In this class, 3
3 what?
significant digits.
Okay, this one has 2.
Yeah, this is that's just because it's an example. Okay, now that takes us to the essential question I want to ask you. Do you understand how to convert, how that ratio works? Now, if I gave you the opposite way, would you be able to do it?
Probably not.
Okay, so let's do one more the same way. All right, one more the same way.